In this fourth section of Chapter 5, we are going to be looking at completing the square. Completing the square is another method of solving a quadratic that uses square roots. We will also be looking to see how we can write our equations back into vertex form. In the next section, we'll be seeing how completing the square will get us the quadratic formula. And in Chapter 10, we'll be using completing the square to work with conic sections. So starting out, before we actually complete the square, we're going to be solving using some square roots. So if we look at an equation, x squared equals 9, well, we think, what squared equals 9? 3 squared equals 9 is the obvious answer, but that's not the only answer. Negative 3 squared also equals 9, because a negative times a negative is a positive. So when we have this, we have two answers. X could equal 3 or x could equal negative 3, which can be written as x equals plus or minus 3. That means the exact same thing as the line above. This leads us to something called the square root property, which says if a squared equals b, then a equals plus or minus the square root of b. So we can use this to solve some equations. If x minus 2 squared equals 16, we think, well, what squared equals 16? Let's plus or minus the square root of 16. We can take the square root of both sides to get that. The square root of 16 is just 4, so x minus 2 equals plus or minus 4. From there, we can add 2 to both sides. X equals plus or minus 4 plus 2. This is two answers. Plus 4 plus 2 is 6. Negative 4 plus 2 is negative 2. So x could equal 6 or negative 2. Looking at another problem that's similar, x plus 3 squared equals 7. Might be thinking, what squared equals 7? That might be unpleasant. Well, plus or minus the square root of 7. And so then we can subtract 3 from both sides, get x equals negative 3 plus or minus root 7, which a lot of people get kind of freaked out here because it's, oh, this is going to be a harder problem. Actually, it's easier. We don't need to simplify. Negative 3 plus or minus the square root of 7 is the answer. We're done. We can move on to the next problem. So try this problem. X plus 2 squared equals 36. Go ahead, pause the video, try the problem, and push play again when you're ready. How do you think you did? Do you think you got it? Well, let's check. We can square root both sides. X plus 2 equals plus or minus root 36, which is just 6. We can subtract 2. Positive 6 minus 2 is going to be 4. Negative 6 minus 2 is going to be negative 8. Did you get x equals 4 or negative 8? If yes, fantastic. If no, try and see where you went wrong. So how are we going to use completing the square to solve? And what is completing the square? Completing a square is a process where we can take something like x squared plus 8 equals 6x and turn it into something squared equals a number. This is kind of a confusing process. There's two steps that we kind of do back and forth simultaneously, and so it gets a little bit confusing. So make sure you're paying attention here. The first thing we need to do when we're completing the square is we need to get all the x's, the x squared and the x's, to one side, and all the constants to the other side. So we can subtract the 6x and subtract the 8, and we get x squared minus 6x equals negative 8. Notice I left a space here. That's because there's going to be something that goes there. So the other step that we're going to do at the same time as finishing this step is we're going to have parentheses squared. The x goes right here because x times x will equal x squared. And so we need to figure out what's going to go here inside the parentheses. The number that goes inside the parentheses is just this number, negative 6, and we're just going to divide that by 2. Put in the parentheses. So we have x minus 3. If we took this x minus 3 squared and we multiplied it out, we'd get x squared minus 3x, which is negative 6x, but then plus negative 3 times negative 3. We're going to square that number and have it up here. So this x minus 3 squared is x squared minus 6x plus 9. Well, we just added 9 to this equation. We can't do that unless we add 9 to the other side of the equation. And so this side turns into x minus 3 squared, and then negative 8 plus 9 is just 1. This is like what we had on the other slide. We have something squared equals 1. We can square root both sides. X minus 3 equals plus or minus the square root of 1, which is just 1. Add 3. 1 plus 3 is 4. Negative 1 plus 3 is 2. So x equals 4 or 2. Let's look at another one like that. X squared minus 4x equals negative 1. Here, all the x's are already on one side. The numbers are already on the other side. So I'm just going to rewrite it, leaving this space because I know I'm going to have to put something there. The next line, we're going to have our parentheses squared. It's going to be x squared equals a number. To figure out what goes inside the parentheses, we're going to take this number, negative 4, and we're going to divide by 2, get it inside the parentheses, negative 2. Then we're going to square that and put it back up in the original equation. If we add 4 over here, we have to do the same thing over here. Negative 1 plus 4 is 3. Now when we square root both sides, we'll have x minus 2 equals plus or minus root 3, which isn't going to simplify. That's okay. We add 2 to the other side. X equals 2 plus or minus root 3. That's the end. That's the answer. If you really need to, you can find a decimal, but this is the exact answer that I would want. Sometimes the problems are a little bit tougher because we have this number in front of the x squared. So how do we deal with that? Because here we just have x squared, and over here we have x squared in the second example. We want only x squared. In fact, it only works if we have x squared. There's several ways of getting around that. The easiest way, and the way that works in everything that we're going to do, is we're going to divide everything by that number. We're going to divide everything by 3. So now we'll have x squared plus 2x equals 1/3. And I left a space because something's going to go there. The x squared is by itself. That is important because now when we complete the square, we'll just have an x. X plus or minus something squared. Well, same process as before. We take this plus 2, divide by 2 to get plus 1. Then we're going to put that, square it, back up in the equation, add 1 there. If we add 1 there, we have to add 1 to the other side. 1/3 plus 1. Well, 1 is 3/3. 1/3 plus 3/3 is 4/3. So you have x squared plus x plus 1 squared equals 4/3. From here, we can square root both sides. X plus 1 equals the square root of 4/3, which, oh, hey, we have a square root of a fraction. How do we deal with that? Do the top and bottom separately. Square root of 4 is just 2. So we have x plus 1 equals plus or minus 2 over root 3. Well, we generally don't like square roots in the denominator, so we can multiply both the top and the bottom by root 3 to rationalize the denominator. We end up with x plus 1 equals plus or minus 2 root 3 over 3. Subtract 1. X equals negative 1 plus or minus 2 root 3 over 3. So this problem, there's a lot of steps here because we ended up having to deal with that square root. That won't always happen, but when it does, that's what ends up going on. So let's see if you can do a completing the square problem. So go ahead and try this one. X squared plus 2x equals 7. Go ahead and pause your video and push play again when you are ready to, when you think you have your answer. So you think you got it? You have x equals something? All right, let's see what it is. Notice here the x's are already on the same side, so we'll spread them out. We have our parentheses here because these are the two steps we're doing at the same time. We're going to divide this 2 by 2 to get plus 1, and then square it, add it up to the top, plus 1, and 7 plus 1 is 8. We can then square root both sides to x plus 1 equals plus or minus root 8. Well, the square root of 8 will simplify. We can do a factor tree. What times what equals 8? 2 and 4. What times what equals 4? 2 and 2. We have a pair of 2's, so those can come outside of the square root. X plus 1 equals plus or minus 2 root 2. Subtract 1. X equals negative 1 plus or minus 2 root 2. And so that's how we can use completing the square to solve an equation. Again, this is instead of factoring, although for the one you just did, and for this middle one, and for this second one we did, factoring would not work. In the first one, factoring would work. We got 2 or 4. We could factor that. That would be okay, but the other ones are not going to be factorable. So completing the square will work even if factoring does not. We can also use completing the square to write the equation in vertex form. To do this, the process is identical. We start out with an equation. We're going to get all of the x's on one side, the x squared plus 14x. We're going to move the 71 to the other side, g of x minus 71. What does g of x minus 71 equal? It equals g of x minus 71. You can't do anything with that. It's just going to hang out. Notice I left a space because something's going to happen there. We're going to have our parentheses squared. Same thing, we're going to take this 14, divide by 2, to get 7, square it, plus 49 on both sides. Negative 71 plus 49 is something we can do. That's negative 21. So we have g of x minus negative 22. So we have g of x minus 22 equals x plus 7 squared. Well, we want g of x equals. So add 22 back to the other side. G of x equals x plus 7 squared plus 22. It's the same process in completing the square. We're just not going to take the square root. We're going to end up with g of x equals, just like we had g of x equals to begin with. Y equals f of x equals. So let's look at another one that's a little bit more difficult because we have this number in front of the x squared again. How do we deal with that? Same thing. We're going to keep these x squared and x's on one side, subtract the 25. Now we're going to divide everything by 2. When we do that, we have h of x minus 25 divided by 2, just sitting there, equals x squared plus 3x. We need our parentheses so we can complete the square. Divide 3 by 2. Well, 3 divided by 2 isn't a pleasant number either. This example will have pretty much everything unpleasant that can happen to you will happen here because we get 3 halves. When we square that, 3 halves squared is 3 squared over 2 squared is 9/4. We can add that to both sides. Now this x squared plus 3x plus 9/4, that is the x plus 3 halves squared. We don't do anything with that. The other side, we'll need to simplify. The easiest way to do that is to split up the fraction. H of x over 2, negative 25 of x over 2, it can split up. Common denominators, negative 25 over 2 is negative 50 over 4. We can add these together. Negative 50 plus 9 is negative 41 over 4. And then add that 41 over 4 back to the other side. Finally, multiply everything by 2. When we multiply the parentheses by 2, it's just going to go on the outside. When we multiply the 41 over 4 by 2, we get 82 over 4, which reduces to 41 over 2. And there's this one in vertex form. And again, this has everything unpleasant happen to you. We have a number here that we have to divide by. We end up getting a fraction here, which when we square it is another fraction. We have to multiply by that. There's fractions all over the place. That's one of the harder ones that you'd ever have to do on these. So let's see if you can do one. So try this one. F of x equals x squared minus 4x plus 13. Go ahead, pause the video and try it. When you think you're ready, push play. So do you think you got that one? Well, let's see. Did you move the 13 over first to get negative 13? And then we already have the x squared by itself. We get our parentheses. Negative 4 divided by 2 is negative 2. Square it. Plus 4 plus 4. Negative 13 plus 4 is negative 9. Add the 9 to the other side. We get f of x equals x minus 2 squared plus 9. That's vertex form. We have a vertex of 2, 9. So if you got that, fantastic. You are ready to go. Be ready for a group activity at the beginning of class tomorrow, and I will see you then.